In a series of 10 videos, I will be looking at the data on the South African Test cricketers from the period of 1991 until 2023. This is basically all the available data for South African Test cricketers as we entered the international fray again after isolation from 1991. So in this specific video, we are going to load the data set and load the libraries and then do some preliminary checks on the data just to get a sense for it. On the screen you will see I have all the items that Jupyter Notebook opens, all the folders on my computer. I am then going to click on desktop because that's where I've put the folders, desktop, YT videos, and specifically SA Test cricketers, and then I open the Jupyter Notebook. It takes a while to open, so just give it a few seconds. Once the file is loaded, you will see that I have put a nice description here of what you can expect in this notebook. And as well, you will see that there is a data dictionary which lists all the columns in the Excel spreadsheet, or the initial Excel spreadsheet, which we will then convert to a CSV file, which allows an easier analysis on Python. So you'll see that I've got here the player, the initials and surnames of the specific cricketers, the span, the number of years playing, the matches, the not outs, run scores, etc. You go down the list here, and there are a bunch of different columns. So there are, or attributes, as what they're also referred to. So just to get a sense of what the spreadsheet includes, it's always a good idea to look at the dictionary, because then you get a sense of the content in the spreadsheet, in the data, and also your domain knowledge can come to the fore because you know or have a sense of or have worked with the data, or you're a keen, in this case now, cricket supporter, which I am, hence me using this. So have a look at the data dictionary. You'll see as well here under type, you'll see here as well under type, there are various types of bowlers, a range of speeds. For example, express pace is 145 kilometers an hour consistently, but occasionally above 150 kilometers an hour. So you can get a sense of the types of data that we are about to work with over here. I also include, although not a specific type of bowler, I include a wicketkeeper category because some players do not bowl. Some players are wicket keepers in addition to batsmen. So I include that over here. And then note, in the context of the data frame, a feature or an attribute is typically called a column. So I'll use those words interchangeably. And that's always important to understand, that the jargon might mean something in certain contexts, but just keep that in mind. So let's look at data pre-processing initially. This video specifically looks at loading the so-called libraries, which allow you to analyze the data using certain statistical methods that are in the actual library. So you see here, I've got the data pre-processing. What I'm going to do first then, if I highlight or click on the particular line of code, you will see that it turns blue. And then for me to run that code, I just press Shift Enter. That little asterisk over there tells me that it is busy thinking. It's busy processing this line of code. Specifically, this line of code then will import these different libraries. Then I will read the specific data. You'll see in this line of code over here, I have put comments. I know it's a comment because there is a hashtag before the wording. So if I look at this line of code over here, there are two lines with two hashtags. This means this line will not run any code because all the words, all the text after the hashtag will not run. So you can use this to assist you to understand your thinking when you generated the code. I strongly recommend that you use comments. These are what we call comments with a hashtag. Please use comments whenever you want to explain your rationale as to a particular line of code, or just to make comments for yourself that'll help you should you come back to the code at some future date. So if I run this code, Shift Enter, you'll see there's no out. Because of the hashtags, there's no output, and it jumps straight to the next line of code. In the next line of code, what I do is I want to load the data set or the data frame. So I specify the file path. In this case now the file name is indicated as I highlight over here, and it is an Excel spreadsheet. So what I'm going to do is I'm going to load the Excel spreadsheet. Then I'm going to ask it in this line over here to change the Excel spreadsheet to a CSV file. Why? CSV files are a lot easier to analyze. They take less space, and because they are smaller files, they allow more maneuverability in terms of the analytics and the space that it takes up. I must also say though, if you do use the Excel spreadsheet as opposed to the CSV file, the Excel spreadsheet does allow you to use bigger data sets as well as more complex data analytics. But for our purposes, we will then use a CSV file of the original converted Excel spreadsheet. So Shift Enter, it's thinking. There I indicated that it must tell me that the Excel file was converted to a CSV file successfully. Now notice what happens here. All these lines of code that I highlight here, if there is no error, then Python will print Excel file converted to a CSV file successfully. So if there was an error in any of these lines above here, there would have not been an output as indicated over here. So that's one way of checking. All these lines of code over here will require to successfully run, and only then will the print function, in this case now, be generated, and hence this output. So let's move to the next line of code. So after I generate line 4's code, you'll see I've made a few comments over here. Read the data, make sure that you include the CSV file name, otherwise it will not read. And then I've given you certain lines of code that you can use should you want to do that instruction. Now you'll see that I've put a hashtag before these two lines of code. That means that they will not run on the back of this line of code being generated. However, should you want to run that code, all you need to do is delete the hashtag. So let me delete that, and you'll see that it changes. And I delete that hashtag, you'll see that it changes. Now I'm not going to run it. So I'm just going to put the hashtag back because I don't want to run it. In fact, I've already run it in this case now. But just so that you know, so I'm reading the data file indicated over here, and I'm giving it the instruction to look at the first 5 from the top cases, in this case now of the South African Test cricketer since readmission. So the first 5 cases are 0, 1, 2, 3, 4, and then it lists all the columns that were in that original Excel spreadsheet file, which was later converted to a CSV file as I did in the code above. You will see that there are several columns, but in the middle here there is a ellipsis indicating that there are in fact more columns than indicated over here. So there are 5 rows in this case because I asked it to generate the head function, and there are 25 columns. And as you can see, there are not 25 columns listed over here because of this ellipsis. So let's take it a bit further now and generate the first 10 cases. So what I did was I included 10 here. So you can include in the brackets whatever number you want, and then it lists those number of rows or cases. You know that the first case starts with a 0, and you instructed Python to highlight the first 10 cases. So the first 10 cases will be 0, 1, 2, 3, etc., until you get to 9. It will not be 10. So always remember the first case is a 0 as opposed to a 1. Right, so the next line of code, as I mentioned above here, the output does not show all the columns. So let's now run code to see what all the columns are. So what you're going to expect now is the output will be very wide because there will be 25 columns listed. So when I pressed Shift Enter, the output 6, you can see now that the code that I instructed over there, it lists or generates the first 15 rows, but it also shows you or generates all the respective columns in this data set. From player right through on your right hand side to handball. So remember, if you're not sure what these columns names are, what they refer to, you can just go right up to the top of the file and you can look at the data dictionary and get an idea of what they include and what they mean. So if we look at this data head instruction code for the first 15 rows, if you just do a preliminary check, you can get a sense for what is happening here. You've got the player names, you've got their span. There you can already see there's something not right over there because there's a number 2001 and then underneath it 2008. Ideally what you would want is you would want to put a hyphen maybe there so that you can tell the reader of this code that the span or the number of years is from 2001 until 2008. You can also see the player as the initial as well as the surname under player. That might be a problem going forward. If you look at the respective columns, you get a sense of the averages, the 100 scored, the 50 scored 0, whether or not they bat right-handed or left-handed. So that's a categorical variable. You look at the innings, number of innings bowled, the balls bowled, runs conceded, etc. Now, what is interesting, there are a couple of columns here that are numerical, but they wouldn't be interpreted as being numerical because there is, in this case now, there's a / in between the 6 for 32. So Python will not interpret that as a numerical variable. It'll in fact interpret it as a string. So that might need some work going forward. You'll see there are a couple of cells here that have nan. Now nan indicates a missing value, not a number. So that might need some pre-processing. If you look a bit further, you'll see there are some cells that have no values in them. And here is a funny little hashtag in the middle of nowhere. So this data definitely needs some work in terms of fixing it. Yeah, you can see there's another indication of a highest score value with an asterisk. So Python will not interpret that as a numerical value. It'll interpret it as a string, which is a problem. If you want to depict a graph or diagram or a table under the assumption this is a numerical value, it won't be interpreted as a numerical value. There's another one over there. There's another one over there. So there's definitely some work that needs to happen over here. There's a common mistake that often happens. Let's look at this line 6 of code. Here where you load this specific Excel spreadsheet, or now convert it to a CSV file, sometimes you might load an earlier version of the file. What will happen then is all the code after this line 6 will in fact use the most recent CSV file that you have loaded as per line 6 over here. So be extremely careful that when you load data, use the correct file. You don't want to be in a situation where you're running code right at the bottom of this notebook and you find that there are variables or cells or columns that are not indicated because you're using the wrong file. So just keep checking yourself in that regard. Let's look at the head 25. In other words, the first 25. Is there anything else that might come across here? You can see row number 19 has got quite a bunch of missing values, and they are pretty much all related to the batting side of things. This is specifically now Charles Willoughby. And you can see Adam Bacher over here. There's also some missing values. So again, you can play around with the value in there to get a sense of the data. If you want to look at the bottom end, instead of using head, I use tail. It gives me from the bottom, the 5 last rows in the data set. So here you get another sense of it. You can see Hamza over here. There's some funny variables, including the cells. There are some missing values or not numbers. And definitely there needs to be some pre-processing over here. You can play around with the number of tail values that you want to look at. Yeah, I've included the number 25. So it gives you the 25 bottom rows that you can have a look at. So we know that there are 25 columns as indicated above. But how many rows are there? 125. And you can see over here, 124, but remember we start from 0, so it's actually 125. So there are 125 rows and 25 columns. The next line of code, you can look to describe the main statistical summary of the dataset. Keep in mind that this only looks at the numerical variable. So you're already getting a sense of potential problems over here because you have many columns that you would regard as being numerical, such as, for example, highest score. But there is, as you can see here, there's an asterisk, which Python would interpret as being a string value. So this will not be included as, or recognized rather, as a numerical value. So you can see there's no highest score over here in any of these columns. So the columns listed here are only numerical columns, and they take the count, the mean, the standard deviation, the minimum value, the first 25 percentile, the 50th percentile, the 75th percentile, and the maximum value. So you get a sense of the data in terms of that. This line of code then shows how the data is transposed. You can see on the columns over here, it's now the statistical measures, whereas on top here, it was the rows, and now it's been transposed in that regard. So if you look at the data just quickly, you are getting a sense that there are definite problems. From a pre-processing point of view, what that means is you would have to fix them. A few of the issues are, for example, that there are funny symbols in the cells, there are missing values, and a few other issues. So you get a general sense of it initially. In the next video, we will do specific pre-processing actions and specifically data types. We'll look at the different data types and what that means and how we can deal with that.